Right now, at this exact moment, something built by human hands is drifting through the space between the stars. Not near the stars, not orbiting them, not approaching them from a safe and comfortable distance. Between them. In the cold and the dark and the almost incomprehensible emptiness that exists beyond the edge of our own solar system. In a place no instrument had ever reached before. In a region that existed only in theory and in equations scrawled on whiteboards. A machine launched from Earth nearly 50 years ago is still awake, still listening. And what it is listening to is something no human being has ever directly heard before. Not a signal, not a broadcast aimed at us from somewhere else. Something older than that. Something that has been there all along, surrounding our solar system in silence for billions of years, waiting for the moment we finally built something brave enough to go out and hear it. That machine is Voyager 1, and the sound it found out there will change the way you think about where we are in this universe. But before we get to what Voyager 1 is hearing right now, you need to understand what this spacecraft actually is, what it was built to do, and why the fact that it is still alive and still sending information back to Earth from 24 billion kilometers away is one of the most extraordinary things our species has ever pulled off. Because Voyager 1 was never supposed to become what it became. It was built for something much smaller, something finite, something that was supposed to end decades ago, and instead it became the farthest object ever made by human hands, and the first instrument in history to physically enter and measure the space between the stars. Voyager 1 launched in September of 1977. The mission was straightforward on paper: fly past Jupiter, fly past Saturn, send back photographs and measurements and data, then drift away into space, become a relic, and float through the dark doing nothing in particular for the rest of time. That alone would have already been remarkable. But built into the timing of the launch was something that made the mission far richer than anyone originally planned for. Roughly every 175 years, the outer planets of our solar system align in a configuration that allows a spacecraft to use one planet's gravity to slingshot itself toward the next, gaining speed without burning fuel, bouncing from giant to giant like a marble, launched through a perfectly arranged track. This alignment happens so rarely that the last time it occurred, the steam engine had not yet been invented. And in 1977, it was happening again. Voyager 1 and its twin, Voyager 2, were built specifically to exploit that rare celestial gift. One mission could do what would normally require several. And almost from the first moments of flight, Voyager 1 began showing the world what it was capable of. It overtook Voyager 2 within weeks of launch. And then, from deep space, it turned its cameras back and captured something that had never existed before. The first photograph ever taken of the Earth and the Moon together, seen from afar, floating side by side in darkness. It was an image that barely anyone had asked for. And it became one of the most quietly profound things humanity had ever seen. A reminder, before the real science had even begun, of just how alone and small and beautiful our small corner of space truly is. Then Voyager 1 reached Jupiter, and the comfortable picture of the outer solar system began to fall apart. The great red spot, observed from Earth for centuries as a neat smudge on the surface of the planet, was revealed as a hurricane larger than the entire Earth. A storm of extraordinary violence, spinning continuously for longer than our entire civilization. The planet had rings no telescope from Earth had ever detected. There were new moons no one had catalogued. But the discovery that stopped the scientific community was not Jupiter itself. It was a small, tortured moon called Io. Voyager 1 captured images of volcanoes erupting on Io's surface in real time. Active volcanoes, live eruptions, happening as the spacecraft watched. It was the first time active volcanism had ever been directly observed anywhere beyond Earth. Nothing about the outer solar system would ever look simple again. Then there was Europa. The surface of that moon, cracked and broken ice, looked disturbingly familiar to scientists who had studied sea ice on Earth. Voyager 1 did not prove there was an ocean beneath that frozen crust, but it gave humanity its first serious reason to wonder. A possible liquid environment hidden under the surface of a moon orbiting a gas giant, a place where the basic ingredients for life might not be absurd to imagine. That possibility drives entire missions and entire careers in planetary science to this day. At Saturn, the rings revealed themselves as an intricate labyrinth of ringlets, waves, and braided structures, more complex and more beautiful than anyone had imagined. But the most consequential discovery at Saturn came from a moon called Titan. Titan turned out to be a world with a thick, hazy atmosphere and a surface chemistry so alien that methane played the role water plays on Earth. Methane rain, methane rivers, a cold, orange-skied world following physical logic our own planet makes eerily recognizable. To study Titan closely, mission controllers redirected Voyager 1 on a path that carried it permanently out of the plane of the solar system. The planetary tour was over, but something else was beginning, something no one had planned for, because no one had truly believed the spacecraft would survive long enough to attempt it. Voyager 1 was now heading outward, past Saturn, past the known planets, past everything familiar, on a trajectory that would eventually carry it beyond the very edge of the sun's influence. For decades, scientists understood in theory that the sun's influence does not simply end at the last planet. The solar wind, a constant stream of charged particles flowing outward from the sun in every direction, creates an enormous protective bubble around our entire solar system. This bubble is called the heliosphere. And for a long time, scientists imagined its outer boundary to be something vague and gradual, a slow thinning, a fuzzy fade from the sun's domain into the interstellar environment beyond. The edge, in the models, was expected to be messy, diffuse, and difficult to pin down precisely. What Voyager 1 found when it finally reached that edge was something else entirely. In August of 2012, as Voyager 1 approached the outer boundary of the heliosphere, the measurements changed. The stream of solar wind particles that had surrounded the spacecraft for 35 years dropped sharply. Galactic cosmic rays, particles originating from deep space outside our solar system, surged suddenly. The magnetic environment shifted. Over the course of roughly 2 days, Voyager 1 crossed from the sun's domain into interstellar space. Not slowly, not through a long, gradual blur, in 2 days, as if it had passed through a membrane, a real defined physical boundary, thin, abrupt, and far more distinct than any model had predicted. That alone rewrote our understanding of the structure of the solar system. The heliosphere was not a vague atmospheric fade. It was a real frontier, held under pressure, and the pressure itself was a revelation. The interstellar magnetic field on the other side of that boundary was stronger than scientists had calculated. The galaxy was pushing back against the sun's bubble harder than expected, compressing our local shelter more tightly than the models had assumed. Voyager 1 did not just cross the boundary, it revealed that the boundary itself had been misunderstood for decades. But the most extraordinary discovery came after the crossing. Out in the interstellar plasma, in the cold and charged medium that fills the space between stellar systems, Voyager 1 detected something it was never designed to find. A low, persistent hum, a continuous background signal at around 3 kilohertz, present not for a moment, not as a single event, but over years of observation. Steady, constant, as if the space between the stars itself had a voice and had simply been waiting for something to come close enough to hear it. That is exactly what it is. The hum is not a message. It is not something aimed at us or produced for our benefit. It is the sound of plasma wave oscillations moving through the ionized gas of the interstellar medium. Charged particles and electromagnetic fields interacting in the vast, low-density environment between the stars, producing a measurable, low-frequency signal that carries, encoded inside its frequency, direct information about the density of the medium it is traveling through. By reading that hum, scientists on Earth can calculate the electron density of the interstellar plasma around Voyager 1 with a precision that no telescope or theoretical model could ever have achieved from inside the solar system. Humanity had spent decades theorizing about what the interstellar medium was like. Now it was sampling it directly, from inside. With a machine built in 1977, the fact that that machine is still functioning at all is, depending on how you look at it, either the greatest engineering achievement in human history or something that simply should not be possible. Voyager 1 runs on nuclear power, generated by the decay of radioactive material placed inside it before launch. That power has been fading for 5 decades. The spacecraft's total power output today is the energy equivalent of a dim household bulb. Its transmitter sends signals across 24 billion kilometers of space, and by the time those signals reach Earth, they have weakened to a level so unimaginably faint that only our largest ground-based antenna networks can pull them out of the background noise of the universe. And even then, every message from Voyager 1 takes 22.5 hours to arrive. Every instruction sent to it takes the same amount of time to get there, which makes what happened in late 2023 almost too dramatic to believe. Voyager 1 began sending back corrupted data, nonsense telemetry, information that didn't correspond to any readable format, as if the spacecraft had suddenly started speaking in a language no one on Earth could decode. Engineers traced the problem to a memory failure inside the flight data system, a critical component of the spacecraft's ability to format and transmit information back home. At a distance of 24 billion kilometers, with a 2-day round-trip delay on every single communication, fixing that failure meant rewriting the software of a nearly 50-year-old spacecraft and transmitting that repair across interstellar space. Then waiting more. Nearly 2 days for the repair to arrive. Nearly 2 more days for confirmation to return. Engineers who had worked on this spacecraft for decades held their breath across a delay that no other mission in history had ever faced at that scale. The repair worked. Voyager 1 came back. Voyager 1. And it is still out there right now, still listening to the hum, still converting the electrical murmur of the interstellar medium into data and sending that data back across the longest distance any human communication has ever traveled. There is one more thing aboard Voyager 1 that belongs in this story. Bolted to the side of the spacecraft, sealed against the vacuum of space, is a gold-plated disc. It contains sounds from Earth. Rain falling, thunder rolling, surf breaking on a shore, wind moving through trees, the calls of birds and whales. It contains music from dozens of cultures and dozens of centuries, from Bach to Chuck Berry to a Navajo night chant. It contains spoken greetings in 55 languages, images of our world, mathematical representations of where our solar system sits in the galaxy, and instructions for any intelligence that might one day find it on how to play the record. It contains the sound of a mother speaking softly to her child. NASA did not include the golden record because it realistically expected an alien civilization to retrieve Voyager 1 anytime soon. It included it because when humanity first built something that would leave the solar system forever, it decided that machines should carry evidence of who built it and why. Evidence that we were here, that we looked outward, that we wondered what was out there and built something to go find out. Voyager 1 is not just a science instrument, it is an emissary. The farthest message in a bottle ever thrown. The quietest and most permanent statement our species has ever made about itself. That is why this matters, and why this mission deserves to be told and retold. Voyager. I rewrote our picture of Jupiter, revealed a volcanic moon erupting in real time, gave us Europa's mystery, and opened the possibility of a hidden ocean world. It showed us Titan's alien chemistry. It found the true sharp edge of our solar system and proved that edge was more defined than anyone had calculated. And then it crossed into the space beyond and found the hum that has been filling the galaxy since long before the Earth existed. Voyager 1 will not last forever. The power is fading. Instruments are being shut down one by one to keep the most essential systems alive for as long as possible. One day, and that day is not far off now, perhaps within the next few years, the signal will stop. The last transmission will cross 24 billion kilometers of space and arrive at our antennas, and then there will be nothing more. Silence. After nearly 50 years of speaking to us from the dark, Voyager 1 will go quiet, but even then it will keep moving, outward, deeper into the galaxy, carrying the golden record into a silence no human voice has ever reached. Long after the last signal is gone, that small machine will still be drifting through the hum it discovered. The low, electrical ancient murmur of the interstellar medium, the background presence of a galaxy that was always there surrounding us, surrounding everything, surrounding the whole brief story of our species on one small planet in one ordinary solar system, in one corner of a universe we are only just beginning to hear. We built something small and brave and filled it with music and the sounds of rain and the voice of a mother and sent it out to listen. And somehow, impossibly, beautifully, it is still listening.